We will explain theory of a flight. Theory of a flight is based on physics principle, which is called Bernoulli's principle. In fluid dynamic, Bernoulli principle states that the increasing in fluid velocity occurs simultaneously with decreasing in static pressure or decreasing in fluid potential energy. Simple form of Bernoulli's principle can be derived, training aircraft. Bernoulli's principle can be derived from Newton's second law of motion. Simple form of Bernoulli's principle is applied for incompressible fluid, moving of gases and the fluid at low Mach number. Mach number, which is dimensionless quantity in fluid dynamics. The Mach number is dimensionless, a quantity that represents the ratio of flow velocity past boundary to local speed of sound. Advanced form of Bernoulli's principle is valid for compressible fluid at high Mach number. Bernoulli's principle uses principle of conservation of energy. The aircraft returns again. Bernoulli's principle uses the principle of conservation of energy. Conservation of energy is total energy of an isolated system remains constant. Bernoulli's principle uses the principle of conservation of energy. In a steady flow, sum of all forms of energy on a fluid accelerating along a streamline is the same at all points at that streamline. This requires sum of kinetic energy, internal energy, and potential energy remains constant, thus increasing in fluid velocity, including kinetic energy, kinetic pressure, and ram air pressure occurs increasing in fluid velocity, including ram pressure and kinetic energy, occurs simultaneously with decreasing in static pressure of a fluid or fluid potential energy, including internal energy and potential energy. Bernoulli's principle can be derived from Newton's second law of motion. If a small volume of a fluid is flowing horizontally from high pressure region to low pressure region, thus there is high pressure behind than in front, it gives net force in the volume accelerating it through streamline. Application of the Bernoulli's principle on the theory of a flight on aircraft wing here, because of the form of the wing here, which is called airfoil, the airflow into which the aircraft flies is split here at the leading edge of the wing. This is leading edge of the wing, passing over and below the wing at different speeds and reuniting at the same time at the trailing edge of the wing. This is trailing edge of the wing. Now, upper surface of the wing is curved. Upper surface of the wing is curved. The aircraft training returned again. Let us return to Bernoulli's principle, theory of flight. Upper surface of the wing is curved, so the airflow over the wing will move faster and speeds up and stretches out, which decreases air pressure over the wing. In contrast, lower surface of the wing is straight, where pressure and velocity are about the same. And since high pressure moves always toward low pressure, yes, air pressure below the wing here, air pressure below the wing pushes upward toward air pressure over the wing. Air pressure below the wing pushes upward toward air pressure over the wing. This is called the downwash movement. And since the wing is in the middle, it is then lifted by perpendicular air force to the wing. Downwash movement is a change of air direction, airflow direction generated by airfoil as major part of lift producing process.